Welcome to this lesson, Introduction to Blockchain Development, presented by Coding Bootcamps. Smart contract functions. And a little review about our instructor. And a review about other courses you may want to take, which will help you, give you additional knowledge beyond what we've discussed. So what we learned so far, we took a look at smart contracts, constructs. We took a look at remix. We saw our Ethereum networks, and we saw that blockchain in general, it needs to be mined. Ethereum needs to be mined, and we learned about hashes and cryptology. So now we're going to be talking about functions in smart contracts. So functions in smart contracts, at least in Solidity, are very, very similar to functions in Java and C++. So if we can take a look here. Functions have visibility, so they can be public, private, internal, or external. It's an executable block. So a function is an executable block that performs some kind of an operation. Functions can take or return parameters, or they don't have to. They don't need to take anything or return anything. It's perhaps they just do something behind the scenes or pass a value back. So public functions are visible and they can be called by other functions in the contract interface. So it's important to know to understand the visibility of your functions and also how they're structured within your contract. So we can see here we have a public function called get and another public function called set. The get, in this case, it returns two string values. In this case, we can see here it receives two values. So private functions are only visible within their own contract. So that means functions within their contract can call them. Private functions can be called by other functions within their own contract, but cannot be called by any functions in another contract. And functions declared as external can only be called from other contracts. So we can declare this in our current contract, but it can only be called from another contract. And we can see here that we have the function setInt, which is private. So again, it can only be called within this contract. But we see here setInt, which takes an integer. We can see it's being called down here in a different function. So we can see setInt with the j, which in this case is going to be an integer 256. And then this will be performed. These steps will be performed. So functions and data can be called from other contracts. So this is a lot like when you are instantiating instantiating an object in a function within Java. Very, very similar. We use the new command. So this way we declare one contract within another. Let's take a look. So we see here that there is this is a one Solidity file. In this case, it looks like how many? There are two contracts. So contract hold data, and there must be some kind of play on the double A. And then contract user base, so two contracts. Notice here, contract hold data, it is being called in contract user base, but they're using they're saying that HD is of type hold data, and we are instantiating a new hold data here, which calls in this case the implied constructor. There's obviously no constructor here, so it's running what's called an implied constructor. So now all of the functionality of hold data is available to user base through this HD contract right here, HD object. Solidity supports calling functions from other functions. And again, a function may return data, may not. It may take parameters, it may not. A function is called in the exact same way that it's called using Java, C++, or JavaScript. So again, here we have our function user count, which is down here. Notice how function user count is being called from, in this case, within the same contract. And it's internal in this case. So this public function add user the user count can only be called from within this contract. So as discussed earlier, functions can be called from another contract. The other contract must be instantiated again using new. So we already talked about this. So I can call hold data contract, but I've got to instantiate it using the new. And we saw an example of that a little bit earlier. Now I have HD available, and I'm able to call all of the data, all of the data types, and all of the functions that are part of hold data. If we went backwards a little bit, we would see that hold data has a public integer called data. And we can see that we're actually returning it right here. So this is a different contract, but we're actually able to call that public integer from the HD contract or hold data contract. Inheritance. So Solidity supports inheritance and polymorphism exactly the same way or similar to how Java and C++ support it. Inheritance between contracts is implemented using the is keyword. So inheritance is defined in the function header, and multiple inheritance is also supported. So if we take a look here, we can see that there is a contract here. In this case, well, again, there's two contracts. There's a contract called basic data, which has, looks like two public integers and has a function. And we'll write another function called user base, and then we'll use the is keyword in basic data. So now these two public integers are now available to user base, and this function is now available to user base. Also, we can also add to it. So user base is also not an exact duplicate of basic data. It also has new functions and new data that we are adding to it. So we can add other public integers and other items in here to then, that is the polymorphism. Now, deploying multiple contracts, we have to be careful. So once we compile this one Solidity file. The one Solidity file has multiple contracts. Next, we go to this dropdown and we select the contract we want to deploy. So let's take a quick look. So here I have my one Solidity file with several contracts in it. There's one contract, there's two contracts, and here's three contracts. I'm going to compile, and that compiles the whole file. That's fine. But when I deploy, I have a choice of three contracts that I can deploy. So if I start with user base and click deploy, I'm going to get output that looks like 1, 2, 3, 4, 5, 6. But now I can go up to basic data and I can click deploy, and I can see, okay, now I see three items here. So we've got to understand which contract we're deploying when we're talking about multiple contracts in a single Solidity file. So that's what we're talking about here, is just have to make sure that as we're interacting with this contract in Remix or in some other way, that we are working with the right contract. Return. So we could see here that if a function, if it's declared, if a return data is declared in the header, you could declare it in the header or in the statement. So we can see here that we are declaring here, this is supposed to be the header, the return statement, and then you don't need a separate return in the body, within the brackets or within the braces here, but it is optional either way. So no return is needed if we declare a return in the header. Pure functions, pure and view functions. So a pure function do not update or read the transactions block state values. So those state values must not be changed by any type of a function in Solidity. So because hashes are sensitive to changes, determinism is very key in blockchain. So a deterministic function is a function which will always return the same value every time. So pure functions do not access state values such as address balance. And we know our address balance can change. Pure functions do not access state variables such as block transactions or message. Pure functions only call other pure functions. So this is a function which, again, will return the same value every time. So we can see here that we have a pure function, and it looks like it's making a call to test P here. But notice test P is not a pure function. So, well, number one, we have a warning, and then we get an error here. And then we see if we change test P to a pure function, then we have no errors or warnings. So a view function. So just like pure functions, view functions do not modify the state. View functions do not write to state variables or emit events. View functions do not create other contracts or make ether calls. We can see here, like view functions, like pure functions, only work with other view or pure functions. And there are function modifiers. So function modifiers are a way to test for a certain condition before a function can run. Just like the name implies, it changes the way the function executes. A modifier is like a custom function type. Modifiers are called in the function's header. We'll see it up in the header. And modifiers can be inherited. So in this case, we see only admin. So we set up this modifier here. So you can see this, we declare a modifier saying that we require the message sender be equal to admin. And then when we set up this function, if this function will only run if the message sender is admin. And constructors. So constructors function much in the same way they do in Java, C++, and other object-oriented programming languages. They do the initialization for the contract as soon as it's deployed. They're the first functions to execute when the contract is deployed, or when we first call the contract. So once a contract runs, the whole contract is deployed to the blockchain. Constructors are either private or public, and if we don't have a constructor, Solidity has a default or an implied constructor. So we can see here, this is how a constructor is declared. And again, this is for initialization. And you can also overload functions. So you can have several functions of the same name within a contract. How does Solidity know which function you're calling if they all have the same names? Well, it's the parameters. So the parameter pattern. So as if you have a function or an overloaded function that takes no parameters and then you call it with no parameters, the function with no parameters, that's the one that's going to be executed at runtime. Likewise, it will match the parameters in the header, such as string, integer. How that is called is how the function is selected. Exactly the same way it's done in Java or C++. So we can see here, this contract has two functions called add user. So we have add user that takes two strings, and then add user that takes nothing. So it looks like when we actually run it, Mike Sims, we have two strings right here. It will be this add user that is run when we click this button here. And time, so Ethereum time. So the Ethereum blockchain uses something called epoch time. So it's highly common. It's time that's maintained from a specific point in time called the epoch. And the epoch is the number in seconds since the epoch time. The epoch can be converted to any date and time, and we have function modifiers certainly can read Ethereum time. So it's good to have a function modifier if we say we wanted to start a initial coin offering and we needed it to only start after a certain day or on a certain day. We can put a function modifier there with a date time. And the current time can also be returned using block timestamps. That's another way to do it. And the current time can be compared to the epoch time in the future. So we could see here that maybe opening time for an initial coin offering is whatever this date is, and opening time, and only, as we can see here, will only start when we have only while open, and then we can see here only while open. So we can see here the epoch. So we obviously have to reach this time before this function can run. An address payable. So address payable is an Ethereum or Solidity data type that can receive Ether. Address payable is used when transaction results in payments made to another Ethereum address. So we can see here, if we take a look here, we see address payable right here. So before we do the summary, let's take a quick look at the lab. So we're going to work with a file called many contracts. Now it's very important that when you receive or when you see this file, you are going to see in the comments certain comments wrapped around parts of your functions. For instance, we comment out here where user data is, so we essentially take away the inheritance here. It's very important that you go in, you read all of these steps and remove the comments in the right way. So you're guided through this using step 1, step 2, and so just take a look at the steps. There's a step 3 and a step 4 and a step 5. So follow those through very carefully. We want to paste this into Solidity. Obviously, we need to compile. And then again, we've got to pick which contract we want to deploy. So if we take a look at hold data here, so we know that hold data is instantiated in user base. So hold data and user base should have some items in common. So let's start with hold data. Deploy that. And we see that there are 2 items here, a public integer called data, and you can set the data. So let's type in 15 here and call it. And here this actually does something, right, when we set the data in here. And let's do this now. Let's deploy user base, because user base actually instantiates hold data. And we'll go down here, right below, and we can see here data, and here we call it the data, because we can see here the data, and set my data. So you can actually see here that we are calling we are using HD here, so they have some kind of commonality. So go through this lab. Just going to delete these now. Go through this lab follow the steps and consult your learning materials. So what we discussed here in this lesson was we learned about passing and returning data with a smart contract function, visibility of a function, private, public, calling and declaring functions, function inheritance, pure and view functions, function modifiers, constructors, overloading functions, and payable functions. Please complete the lab and complete this assessment. And please consult your learning materials for other information and additional training. And next we will do client-side applications. Thank you.